we have learned two formulas for the equation of lines. The first is point slope form, y minus y0 equals m times x minus x0. So that's slope, and that's a pair of point. Again, the subscript doesn't have to be x0, y0. It could be x1, y1, x2, y2. It's just any point. And second form, slope-intercept form. M is slope again, but B is y-intercept, which is a special point in y-axis. So there are four types of questions we do to find the equation. Suppose we're given the slope and any point, and it would be easier just to plug into the first formula, and to because m is given, x0, y0 is given as this point. And I'm not saying you cannot use the second form. If you have learned other ways to use the second form to do the problem, you can. If you are given the slope and y-intercept b, we should directly use the second formula. But this y-intercept is a special point. It has to be on the y-axis, which means the x-coordinate must be 0. Whatever the y-intercept is, but x-coordinate must be 0. So if you don't have the special point, you should use the first formula. Now, the third case is given 2 points. If you are given 2 points, we don't have the slope. We have 1 point. When you have given 2 points, of course, we have 1 point. But if neither of them is the special point, y-intercept, you should also use the first formula. But how do you find the slope? And we can use the slope formula, because when we are given 2 points, we can find the slope through of the line through the 2 points. Now, we're going to look at the fourth type of the question. Given a point and a line, and the unknown line so this line is like given, so it's the line we know, but the unknown line is parallel or perpendicular to the given line. So in real life, we may have situations like, suppose there is a local road, and then we want to build, the local road may not be horizontal, so it could be a local road like that, and we want to build a highway, construct a highway that is parallel to the local road, and it goes through some point. Let's say we wanted to go through like maybe a gas station, or maybe a school or something. And so there is a given point of the location of the school can be described by a point. So we have this type of question. It's like we have to have a certain steepness, which is the slope, and we have a point. Or maybe not necessarily parallel. It could be maybe we want to construct another road to be perpendicular to the given road, and also it must go through a school or something. So that's the type of question we're doing. And to use a mathematical equation to model the new road we're going to construct, and we need to find the equation. So let's look at example. Write the equation of the line that contains the point 3, 5. So 3, 5 is sort of like the school, the location of the school, and is parallel to the line x plus 7y equals 4. So this line equation models the road we already have, and the old road, and then we want to construct a new road, which is represented by the equation of the line. So the line is the new road we want to construct is the black one. This is the old road, and we want to construct a new road that goes through the school right here, and also it's going to be parallel to the old road. Okay, so we have two formulas. So we're going to use one of these formulas to do this question. As we know that this point 3, 5 is not a special point. It's not the point on the y-axis because x-coordinate is not 0. And so we may consider using the first formula, point-slope form. But in order to use the point-slope form, we need to know what the slope is. We do have the point, which is x0 equal to 3, y0 equal to 5. But we don't have the slope. But we do know that the line we're looking for, this black line here, is parallel to the line given, the red line. So this is the old line, x plus 7y equals 4. And we, as you can see, the parallel lines must have the same steepness. And so if we can find the slope of the line given, and we will be able to get the slope for the unknown line which we're looking for. So let's see the line given. So we're given the line x plus 7y equals 4. And we do have a name for this form. We call this standard form. And the standard form has the variable x and y on the left, and a constant number on the right side. That's called a standard form. But previously we talked about these two forms, and we know that if we know the number in front of x, or in front of parentheses, that is the slope. So in order to find the slope, we must get this in one of the forms. It's easier to get into the second form, point-slope form, because point-slope form, we must have y on one side by itself and everything on the other side. So that's what we're going to do. We're going to try to get y by itself. And similar to what we did before, so how do we solve when we solve equations? How do we get something by itself? So we first have to get rid of this x. We subtract x from both sides. X minus x is 0. So we get 7y equals 4 minus negative x. I'm going to put 4. This 4 means positive 4. So I'm going to switch them. I put a negative x plus 4, which is the same as 4 minus x. The reason I do this is I want to get into the form I want, slope-intercept form. I want to put x first. But if you want to leave it as 4 minus x, it will be fine. Let me write down the slope-intercept form here, mx plus b. So that's the form I want. I want to convert the standard form to slope-intercept form. So that's why I put x first. But if you want to do 4 minus x, just remember the number in front of x will be the slope. But we're not there yet because we need to get y by itself. We still have a number 7 in front of y. So we can divide both sides by 7. Now, so 7 divided by 7, we get 1y. On the right-hand side, we need to separate these two terms. So we got to do division. And notice the number in front of x is just an invisible 1 there. Let me put that 1 there to remind ourselves. So we're going to have negative 1x divided by 7. So which gives us negative 1 over 7x. That x, you can leave it on the top or move it right next to it. They are equal. We mentioned this in one of the videos because when you multiply negative 1 7x means negative 1 over 7 times x over 1. So when you multiply straight across, you are going to get negative 1x on the top and 7 on the bottom. All right, now let's continue to divide the other one. So we divide 4 by 7. Positive 4 divided by a positive 7, we get a 4/7. So this is the form we want. A y on the left by itself and something times x, negative 1/7 times x plus b. And we don't really need a b here in order to use the first formula. And plus this b is not the, this y-intercept is the y-intercept of the old road. It's not a y-intercept of the new road we're going to construct. So let's use the point slope form. So let me write down the formula first. Y minus y0 equals m times x minus x0. And we plug in numbers. Now we have y0, which is 5, equals m is negative 1/7. Negative because negative 1/7 actually is the slope for the old road, how steep the old road is. because they are parallel. So the new road we're going to construct must have the same slope. So we're going to use the same slope, negative 1/7 times x minus x0 is 3. So 3, 5 is like the location of a certain school that we must construct a road through. Okay, so this is the slope-intercept form then. Point slope form. You can leave your answer this way. If you want to get rid of parentheses, you can multiply and get rid of parentheses. And if you want to move the 5 to the right, you can continue, but you don't have to. So this form we have is called point slope form. You can convert it to slope-intercept form or convert it to standard form, whichever you want. But again, this is acceptable, unless the question specifies that you have to convert it to a certain form. Otherwise, you can leave it in any form you want. Now let's look at the next question. So this question is almost the same as the previous one. We have a given point. This is our x0, y0. But instead of having parallel, we had before, we have perpendicular. So perpendicular to the line given. This is the other situation I mentioned. So you have an old road, but this time, and you also have a school here, but we want to construct a road which is not parallel to the old road. We want to construct a road to be perpendicular to the given road. And there is another relationship between perpendicular lines. So we know parallel lines, they must have the same slope. But perpendiculars, of course, they don't have the same steepness. So first, we're going to find out, say, let's the given line, we want to find out how steep this is. So we have to do the same thing we did to convert this to slope-intercept form. Because in this form, we can see what the slope is very quickly. So get y by itself. So first, we can maybe add y to both sides. So let's start with this and add y to both sides. And now we have 3x equals y plus 7. And then we're going to move 7 to the left. So I have y by itself. The other way is you can subtract the 3x and then divide by negative 1 in front of y. You will also get the same thing. So let me switch the left-hand side and right-hand side. So that is the slope-intercept form. The number in front of x is our slope, which equals 3. So the given road, the old road has a slope 3. The line that is perpendicular to another line will have a different slope, which is equal to, I'm going to call it m prime. The two operations. First, you flip it. So 3 over 1, we flip it to get 1 over 3. And also the opposite. So there are two of them. So now we get the slope of the line we are going to construct. And let's plug into the formula, point slope form. So we get y minus y0 is 5. M is negative 1/3. This is negative 1/3 here. Times x minus x0 is negative 2. Minus negative 2. You can change it to plus 2 because of the keep change rule. So that would be the answer. So in these two questions, we are given a line, but we need to first convert it to a slope. Step 1, you want to convert it to a slope intercept form. When you get this slope-intercept form, this is called a slope-intercept form. When you get this form, the number in front of x is always our slope. So that's step 1. And then step 2, we're using the relationship. It's either parallel or perpendicular. If it's parallel, the road we're going to construct must have the same slope, negative 1/7, negative 1/7. But if the line we're going to construct is perpendicular to the given line, then you will have to do the opposite reciprocal. Opposite reciprocal. So 2 steps. Take the reciprocal and flip it. 3 over 1, we get 1 over 3. And then put a minus sign in front of it to get the new slope. And then you can, step 2, This is step 1. Step 2, they use the point slope form.